Welcome to the Unit 2 review. The first thing that we looked at in this unit were our square roots. Now square roots are written using a radical, which we all are very familiar with, and it looks something like this. The number under the square root, and I'm going to choose a perfect square root, is solved by finding two equal factors that will multiply together to get that answer. I know that in order to get to 25, I know that 5 times 5 is 25. Therefore, the square root of 25 is 5. My question to you is, when do we use square roots? Well, the answer sort of lies in the question here. Remember that we are looking at a square. I'm going to choose a smaller number here. I'm going to say that I have a perfect square, use your imagination a little bit, that is 3 by 3. I know that the area of this square is 9. So if I sit here and I count 1, 2, 3, 4, 5, 6, 7, 8, 9, the area of this square is 9. So how do I figure out the side length? Well, of course, you're all thinking, count them, Miss Norman. Of course, I can count them. But what happens when the number becomes so large that I'm looking at an area that I don't want to have to sit here and count every single square? I can find the length by taking the square root of 9, okay, which is equal to 3. So I know that our side lengths, remember length times width is area, 3 times 3 would give us our area. So when I square root the area, it will give me my length.
Yeah, y'all know what it is. Mathematics. Perfect squares. Let's go.
I know you are looking around everywhere, looking for some perfect squares. I'm knowledgeable in many things. I know many things, almost everything. Give me a number quickly, times by itself, and you'll see that you will get a perfect square, a perfect square. A perfect square. So you wanna play with numbers? You see them coming at you with great force. A perfect square is the answer to a number multiplied by itself. Are you ready for a perfect square, perfect square? 'Cause once you start,
you'll be right on track.
So we know that perfect squares can be found by multiplying any number by itself. 1 times 1 is 1. 1 is a perfect square. 2 times 2 is 4. 4 is a perfect square. And so on. I can go on. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6, 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. And 12 times 12 is 144. You could continue this list by continually going 13 times 13, 14 times 14. Any number that is a product of the number multiplied by itself will give you a perfect square. To estimate a non-perfect square, we need to find the perfect squares that are on either side of our question. The square root of 32, I know will be between the perfect squares of 25 and 36. So 32 falls in between 25 and 26. I'm going to place these on a number line. I will have the square root of 25 at the lower side. The square root of 25 I know is 5. I'm going to put the square root of 36 on the upper end, and I know the square root of 36 is 6. What I like to do first is then find a middle point. I know on the bottom between 5 and 6, I know I have 5.5. In between 25 and 36, there are approximately 11 places. That means that the middle will be about 6. So if I add 6 to 25, I know my middle piece, my middle piece will be approximately the square root of 31. I'm looking for the square root of 32. Now if I can place 5 places in between here evenly, 1, 2, 3, not quite evenly, but I can still see the trend. The square root of 32 will be somewhere in here. So square root of 32 will be the next number on our number line. So I'm going to say it's about 5.7. This is an estimate. I know it's greater than 5.5 and less than 6, but I also know that it is closer to 5.5 than it is to 6. So an estimate for this one would be about 5.7.